Okay, perfect. So yeah, thank you very much for hosting me. Happy to be here. So I'm actually going to talk about pass-through exploitation. So there is a research we've done at Cymulate. So I'll introduce us and the research in a few seconds. But as you kind of giving a little bit on the agenda, really just a quick introduction to me, the team, and of course the research that we've done. We'll give an overview of pass-through authentication because I think the main research we've done was researching the hybrid environment between like an on-prem Active Directory and Azure Active Directory and the connection between the two. We'll give an overview of the attack, show a demo, kind of even like a video demo, a nice one to show exactly what's going on, and talk about the potential impact of this vulnerability that we found. And of course, we'll leave maybe even a few minutes for questions. So just introducing the team. So my name is Avihai Ben Yossef. I'm one of the co-founders and the CTO at Cymulate. So what we aim to do at Cymulate is, attack simulation. That's kind of the whole idea of the company and the product that we've built. And that's where most of our researchers come from. We're looking for different attack scenarios that might exist in different kind of environments because of, features, things that can happen, things that attackers can exploit, why they can do it and how they can do it. And that's also what led us. We focused a lot on hybrid environments. A lot of our enterprises are these kind of hybrid environments, and that was a key factor and a key parameter that led us to create that, to research these kind of capabilities in the environment. You also see here Ilan and Elad. So they are the ones that actually conducted the research. I'm just stealing their credit for like these next 30 minutes. Unfortunately, they couldn't make it, so I'm giving this talk in their behalf. Oops. So, pretty straightforward. I think, like, again, a very quick introduction to, of course, cloud and cloud services. So pretty straightforward idea. The adoption of cloud is pretty intense, and I think, like, there's so many workloads and SaaS application these days. There is, I would say, any enterprise has moved some of their services to the cloud by now, okay? Even if it's a few, if it's some, if it's all of their services, but the adoption is 100% increasing rapidly. And that's why we took that initiative to validate, how does that look like if somebody is actually adopting cloud services, specifically in a Microsoft environment, what are the concerns that lead from that perspective? Okay, so the entire presentation will be about pass-through authentication. That will be that service that we're going to talk about. But really, why did we actually tackle the pass-through authentication? Okay, so there are a few points that led us to research the pass-through authentication service, which I'll go further on through the presentation to explain what is that pass-through authentication service. But again, a very widespread adoption. So cloud adoption is of course increasing, as we mentioned, but companies and environments, they don't just at first step move all of their workloads and all of their services to the cloud. So they do use that, what we call, it's called AAD Connect, and the pass-through authentication. They do have still an on-premise environment and a cloud environment. There is still something that connects between them. And that will be that pass-through authentication that kind of enables all of that to happen. So there is a very widespread adoption of the pass-through authentication on Microsoft environments. The second would be the fact that this service is very critical inside the identity infrastructure. When you have I think these days it's okay to say identity infrastructure. The identity of an entire company environment is an entire infrastructure built behind it, and the pass-through authentication is a very critical factor in the identity infrastructure. And the last point is, and I'll show later on why is that right. It is a very high value target. So if an attacker gets access or ownership on the pass-through authentication service, there is a lot of impact to that point, and that's why we also targeted it. And again, I'll go through it throughout my presentation. So let's give a quick overview of pass-through authentication. So I think it's as we mentioned, we're talking about hybrid environments, in this specific case, like an on-prem Active Directory environment and Azure AD on the cloud. So a pretty simple process, very straightforward. If somebody wanna sign in, and a user signs into like a cloud resource, for example, he is being redirected to Azure AD for authentication. He logs in, puts his username and passwords. It goes through the pass-through authentication service. The pass-through authentication service then forwards that request to the domain controller on-prem. If the username and password are indeed correct, it forwards it back to the Azure tenant saying, that's a valid credentials. Go ahead, let him access the resource that he wanted to get. Pretty straightforward. Nothing very crazy about that. Okay, oops, that's too much. Okay, so very abstract of how does the pass-through authentication works. So when you install the AD Connect and the service on-prem, the first thing it does, it's like a bootstrap. It initializes a connection to the Azure AD tenant using the relevant key. It then starts, and basically what it does at that point is signs up to like a queue that Azure has. So that will be like a queue that whenever somebody logs in, it's being written to that queue, and every time, we'll say there is like a polling mechanism on the PTA, on the pass-through authentication service. It's going to try and pull every time that somebody logs in, it's going to be written to that queue, and the pass-through authentication service will pull it from that queue. But that's very abstract, very straightforward. It connects to Azure, and then constantly trying to see if there is something it needs to do using that polling mechanism. There is a reason why I'm actually explaining that. As we go throughout the presentation, this will give us some new things that can happen throughout this process. Yep. Okay. So let's go into even a little bit more details. Okay. So, yep. This doesn't really work. Okay, we can leave that. It's okay. Basically, so a user signs in, as we mentioned, username and password go to the, he's being redirected to the Azure AD login page. He puts his credentials. They are being encrypted and sent to that queue. Basically, they are being written on that same queue. The pass-through authentication servers, as I mentioned, is constantly polling from that queue. It takes the username and password to that queue, and then goes to the domain controller that is synced to the Azure AD. And he asks him, are those credentials valid? The domain controller then forwards a binary yes or no answer to that questions. It then forwards back to the Azure tenant saying, yes or no, is that user actually authenticated? Again, nothing very crazy about the pass-through workflow. So, when you think about why is that so important, so I think first of all, user experience, okay? If I'm in a hybrid environment and I have an identity infrastructure as mentioned, I don't want people, logging in with different passwords. I want the transition to a hybrid environment to be as clean and seamless as possible. And that's why that's a super important feature when you want to go hybrid and start moving resources to the cloud. Second thing is it's really, really easy to deploy, very easy to administrate. It's a very, very clean feature that can be used. And of course, it also helps with security, because I think there are so many, throughout the history of security, there is a lot about multiple passwords. So I think there's been done a lot of researches about multiple passwords and how that's not a it's not a best practice for security. You want to reduce the amount of passwords being used in your company. And that's why it's also an important feature. You don't want one username for your on-prem and another one for your cloud environment. Just like any other kind of an SSO concept, very similar idea. But that's definitely the part where that we wanted to tackle. Is it really secured? And maybe there are flaws in this process that needs to be acknowledged. So the first thing that we did, honestly, by mistake, that wasn't even a direction we took, but we just linked or maybe synced two different domains to one Azure tenant. So we created two on-prem domains. One is called A, the other is called B, and we synced them both to the same Azure AD tenant. What we saw at that point is some kind of an inconsistency with logging in. So, oh, sorry, again, jumped the gun there. Some kind of an inconsistency with the login, which means, like, you know when you kind of log into like an app or something and you put the right password and, you know, you get like a bad login and you're absolutely right that the password was indeed correct. You're saying, what just happened? Am I in a phishing right now? Am I being phished? Or, because I'm 100% sure I used the same password, and you know what, I'll try again, and the second time it worked. And you kind of scratch your head saying, was that on purpose? Did something weird just happen? And that's what happened here, which you'll see here on the video. That's exactly what happened. We've logged in, oops, sorry about that. We've logged in one time with one of the on-prem domains, and what happened is we got an error saying you cannot log in. But we were absolutely sure we were using the right password. Sorry, I'll just play the demo. It's not playing, right? I do want to click that play. I think it's so one slide back and click play, please. Okay, yeah, that's good. Perfect, okay. So you can see here we've used the right password. That's one of the on-prem domains, username and password, because we are in a hybrid environment. This is a sync domain. And for some reason, like I've mentioned, we didn't really know why. We got bad login, but we were absolutely sure we're using the right password. We've tried it again, and for some unknown reason, we did get logged in. So that led us, okay, that's definitely something we should investigate. Why did that happen? This is not a phishing domain. This is the right domain. This is the right link for the Azure portal. Nothing has changed. What you can see here, we've started decompiling the PTA agent. We started thinking maybe something with that password authentication agent is off. So we decompiled it. This is a .NET agent, so we didn't have to like reverse engineer assembly code or anything like that. We decompiled it with a different kind of .NET decompile tools. And what you can see here is something nice. So you can see the who am I here. You can see the domain we are currently on. But what you also see here on the debugger, that the domain that got to this PTA agent is not the same domain that we have logged in with. It's a different one. So the reason why we weren't able to log in was because this is not the right domain. We have used domain A, and we've got to domain controller B, which didn't know who is domain A. Why did we get a different domain controller? So we said we connected A and B to the same Azure tenant. For some, we've logged in with the username from domain A, but we got the request to domain B. Okay. That's definitely a question we started asking more what happened right now, and not only that, like what can happen more than that. We'll get to that in a few minutes. So what we started thinking, okay, if I'm an attacker and I want to exploit this fact that I can log in with domain B and it will get to the domain controller of domain A. So we started creating like a POC. We created a DLL that we're going to inject into the PTA process. So it's going to be like a .NET DLL, like a managed DLL, that we're going to inject into it. Basically, we're going to use the CLR of .NET. We're going to inject to it. We created an unmanaged DLL that's going to hook those functions. Basically, at the first, there is the validate credential function. We're going to hook and filter traffic to that function, basically owning the authentication and a post. And using that pre-authentication, once we hook to that PTA agent function of validate credentials, we're going to just print out every different credentials that come into the PTA agent just to show us what we can see there. And of course, the second thing we thought about doing is why not return true? Every time somebody tries to log in and there is a validate credentials request to the PTA agent, we'll just return true. And whatever as anybody's trying to sign in, doesn't matter. We'll just let him in, forcing like a true, like an authentication, a successful authentication on the PTA agent. So the attack process, the steps is basically a user logs in, okay, from domain from domain B, and it goes throughout that same process that we've mentioned all the way. With like the fact that instead of going to domain B, it's going to go to domain A, because as we mentioned, we got two domains connected to the same Azure tenant. We don't know why, but for some reason, it can land, the authentication request can land at domain A, domain controller. And if we are hooked to it, we can just say, yes, you are authenticated, go ahead. And that's what we did. So you'll see here, the manage DLL, as we mentioned, it will basically print like a prefix of the function of the validate credential. It will just print out to a log file all the credentials that got to the PTA agent. And a postfix, it will return true every time somebody tries to sign in. There is also the unmanaged DLL that is actually being injected. Not very interesting, but basically loading CLR and then loading the managed DLL that's going to help us bypassing the PTA agent activity. Yes, let's go for, okay, so let's see the demo of the attack. Let's hope it plays. And if not, we'll just go and click play. I don't know who's going to click, but yes. But I think you're about to see probably, pretty straightforward to what I've mentioned. We're going to manage basically we're going to first start with injecting. So we've used Process Hacker to inject the unmanaged DLL into the PTA agent on that server. And we're going to start logging in, in different credentials, different usernames and passwords, and let's see what happens, So we're just like I've mentioned, I don't know which domain controller these sign-in are going to land. Domain A, domain B. It's pretty random. I'll give a possibility of how is it working, but what you'll see in front of you, we can, every time we log in, at that moment, basically we let everybody in. Everybody can now access Azure. It doesn't matter what you put in the username and password. It can be user from domain A, user from domain B. If the authentication request lands in our PTA agent, the one we are hooked to, that's it. You are logged in to your Azure portal. You can reach out to those resources. And of course, one nice side effect, we can also list out the different credentials and start packing them up, and every credential that gets to the PTA agent that we are currently hooking, we can just list them out and start gathering more and more credentials that's being logged in through that pass-through authentication service. You can see throughout the demo that we're trying, it doesn't really matter what we're putting in, but the nice thing about it is that if somebody connects with a different domain, if that username and password is from domain B, and we are hooked to domain A, we are logging him as well. He's still logged in. He's going to be logged in, and he can actually get different permissions. Okay, that's also at that point like a permission issue, because at the end of the day, if you can log in from even a different domain from the one that should be, maybe you have a different role on that same Azure tenant. And that's a classic privilege escalation idea here. I'm on a totally different on-prem domain, and at that point, I've managed to get a privileged user from a totally different on-prem domain on a cloud environment, on a cloud portal, on a SaaS of the Azure, not even related to the on-prem domains. That's a totally, I would say, like, if you think about the attack scenarios, and that's what we're kind of researched here, if an attacker managed to own and attack an on-prem domain and get to the PTA agent, not only that he can get to other cloud resources that might not even be a part of his own domain right now, he can also even move laterally to a totally different on-prem domain as well, which might not have any relation between the two, just because he's managed to get access to that PTA agent in that same domain. And yeah, you can see here in the last kind of seconds of the video, this is a totally different user that has the same access to the Azure tenant, and he's a global admin on Azure, and we just got there just from being an administrator on an on-prem server with the PTA agent, totally unrelated to the Azure portal. Yep, give me one. Okay. So the potential impact, I think I've mentioned a few of them along the way. First of all, unauthorized access to Azure services. So again, an attacker that got access to your on-prem domain, domain A in this example, can start now getting more access to more Azure resources that he just didn't have before. The second would be credential theft. So once I'm on that hooking of the PTA agent, as I've seen on the video, you can just print, start logging different credentials, and you might find their credentials from not only from domain A, but from domain B, maybe C, maybe D, maybe E. Who knows? Who knows who's going to try and log in, and those credential requests are going to get to the PTA agent that we are currently hooking on, because that's totally random. So if two domains are connected to that same Azure tenant, whether they go to domain A or B, you don't really know. What we have seen is it's probably because of that polling mechanism that I've mentioned earlier. So if you connect two domains to that same Azure tenant, it's probably a race condition between the two. Both of them are polling from that same queue, from that Azure queue, and whoever pulls it first got the request. So there is no way to control it. You don't know where that authentication request is gonna land. But if it landed on the domain that you currently, or on the PTA agent, sorry, that you currently hook, that's a win. You can start moving laterally to other domains. And that's the way you can escalate privileges to Azure services, or even to another on-prem domain as well. So that can actually lead to lateral movement between two different on-prem domains. It has zero connection between them. Their only mistake that they've done is that they are both synced with that same Azure tenant. That's it. And that's a totally new paradigm to protecting your on-prem environment and your cloud and Azure environment. And that's a pretty big win for an attacker that managed to attack a domain. Getting to a totally different domain, getting to escalating privileges on your Azure tenant, hopefully getting even a global admin, from owning an on-prem domain all the way to getting global admin on Azure, getting domain admin on a totally different domain and domain control. That's a pretty big win for an attacker that just managed to get access to a server with the PTA agent on. So some of the mitigation strategies that we, of course, recommend to handling with this kind of an attack scenario is, first of all, MFA will probably do a lot here. So there was also an article with on Forbes about Microsoft, of course, issuing a lot of mandatory MFA logins in their services. This would, of course, solve a lot of these problems right now. They've even referenced because of the research that we have done, they've also referenced that as, again, a driver to implement and enforce MFA on login attempt, because in this case, yes, MFA would have solved the issue. You could not have logged in because you have been redirected at the end to enter your second factor, and that would have killed the entire process here. One more thing that I think is also important to mention is that PTA agent here, it's not by necessary something that is installed on your environment as a tier 0 server. It can be installed in your domain controller. It can also be installed in a different server that has a connection to the domain controller. This PTA agent is not something people talk about or know too much, but if you have that AD connect with that PTA agent in your on-prem environment, this needs to be highly monitored, okay? This is not a regular service in your environment. If an attacker gets to the PTA agent, he has a lot of control of your authentication, not just on your on-prem environment, but on different domains that might be synced with the same Azure tenant. It means that it has a lot of control of your Azure tenant as well. There is a lot you can do just by having administrator rights on your PTA agent server, as I've shown throughout the presentation. So of course, we've cooperated with Microsoft, with MSRC. The first thing we of course suggested is, first of all, that kind of a multi-domain lateral movement capability that popped up from this research. First of all, make the authentication process domain aware. It doesn't make sense if I'm gonna authenticate from domain B. I should be referred to the pass-through authentication of domain B, not domain A. This should not be only a polling, like a race condition, who gets it first. You can do a validation that the domain that was entered in the username is indeed domain B. So of course we've offered that. And yeah, and there are different kind of logical separation and segregation between domains that should be implemented during this process. And really just a summary of the report and the timeline. So I think we have reported this at around July to the MSRC. They given us a feedback very quickly, as you can rightly see here, with the fact that they acknowledge this. It's not currently listed as a CVE, but they have acknowledged, and of course they have invited us here to even share it with the crowd. And they do see that as something that needs fixing, but not currently posing as an immediate threat. And yeah, and I think the team, not me, the actual team that did the research, will also be listed in the Hall of Fame of Microsoft as MSRC. That's it. Thank you for listening and thank you for inviting me on the Microsoft team. And we got here the emails of the two nice guys that actually did their research. If somebody want to reach out to us or get some more details about it and how to, maybe implement some of the mitigation strategies that we've offered here, we are happy to create that connection. Thank you very much.